very good.
Okay.
All right, so this is number 47. You have y equals the sine of x times the cosine of x on the interval from 0 to 2 pi, or 0 to pi over 2. And so this problem is different because you have a closed interval. So you're going to find your critical numbers by taking your derivative and setting it equal to 0 and seeing where it's undefined. But then you're also going to test your endpoints to decide whether it's a max or min. You're not going to use the first derivative test because you have a closed interval. Does that make sense? Okay, so y prime is the derivative of the first. The derivative sign is cosine times the second, which is cosine x, plus the derivative of cosine, which is negative sine x, times the first, which is sine x. So the derivative simplifies to cosine squared x minus sine squared x. And we set that equal to 0. So really, there's a couple ways that you can tackle this problem. You might remember that that's a double angle formula for cosine. That's actually the cosine of 2x is equal to that. If you look on your trig identities, that's the double angle formula. Do you remember that?
I remember it vaguely from pre-call.
Good, yeah. Okay, so that's really the best. The other way is to just kind of try and figure out when does the cosine equal the sine, because that's, if you moved it over, that's what you're asking for. But here, when does cosine equal 0 on the interval from 0 to pi over 2? Well, that actually happens at pi over 2, right? You agree with that? The cosine...
Wait.
Go ahead.
Sorry, what did you just ask?
Okay, where will this be true? Where will it be true that the cosine is equal to 0?
Oh, okay, yeah. And that'll be... I've forgotten that, but I'll memorize that.
It's at pi over 2, okay?
Okay.
So what that means is if you took the cosine of pi over 2, you would get 0. Well, this means that what you're taking the cosine of needs to be equal to pi over 2. So 2x needs to equal pi over 2. Does that make sense?
Yeah.
Because what you're taking the cosine of has to equal 0. And if you take the cosine of pi over 2, that equals 0. So this 2x has to equal pi over 2.
Yeah.
And then you just divide both sides by 2. And so you'll get x equals pi over 4. So that's your critical number.
Okay.
And then what you do is you test your endpoints and your critical number back into the original function. When you have a closed interval, that's how you work these to decide what the max or min is. So you're going to need to do f at 0, f at pi over 4, and then also f at pi over 2. Okay, so the original function was sine x cosine x, so this is going to be the sine of 0 times the cosine of 0. Well, the sine of 0 is 0, so this is just 0. And this is going to be the sine of pi over 4 times the cosine of pi over 4, which you can do on your calculator, but you might remember it's the square root of 2 over 2 for both of these.
Oh, yeah.
So that's square root of 2 times square root of 2 is the square root of 4, which is 2 over 4, which is 1/2. And then at pi over 2, that's going to be the sine of pi over 2 times the cosine of pi over 2. But the cosine of pi over 2 is 0, so the sine of pi over 2 is 1, but that's just going to be 1 times 0, so that's 0. So you're going to have a min at 0, 0, and at pi over 2, 0. And then you have a max at pi over 4, 1/2.
Why is the... Okay, so there are two mins?
Yeah, because they give you the same value.